Good day everyone, you are welcome to class. If today is your first time of joining this great family of scholars, you are wholeheartedly welcome. And to my returning subscribers and followers, thank you for always coming back. On this platform, I teach mathematics and physics, but for today, I'll be teaching physics. Without much ado, let's jump right into what we have for today. But before we start, I want to leave you with this statement that says, what you don't know is more than you. As a result, stay put and watch this video from the beginning to the end so that you can know what you never knew before as far as physics is concerned. Having said that, for today, we'll be looking at the part 3 in the scalars and vectors series, which happens to be the continuation of addition of vectors. And this time around, we'll be looking at the resultant of two vectors that are not perpendicular to each other. If you remember, in the part 2 of the scalars and vector series, we talked about the resultant of two perpendicular vectors. But this time around, we're looking at the resultant of two vectors that are not perpendicular to each other. That means that does not make an angle of 90 degrees with each other, but rather they make an angle of either greater than 90 or lesser than 90. The question now is, how do we find the resultant of these two vectors that are inclined at an angle that is either greater than 90 or lesser than 90? It is very simple. In solving for the resultant of two vectors that are not perpendicular to each other, we use cosine rule and sine rule to find the magnitude of the resultant force or vector and the direction of the resultant force or vector respectively. The question now is, how do we go about it? Just relax. I'm here for you to deliver what you want to get. So, solution. Now, we are taking this question as an example under this resultant of two vectors that are not perpendicular to each other. So let's take this question. It said, if two forces, the force here now is what? The vector, as you know. If two forces of magnitude 2 Newton and 3 Newton acting at a point O, are inclined at an angle of 60 degrees. This 60 degrees, you agree with me, that is lesser than what? 90. So with this 60 degrees, it means that these two forces, 2 Newton and 3 Newton, are not perpendicular. Because if they are perpendicular, this 60 wouldn't have been 60, but it would have been what? 90 degrees. So at an angle of 60 degrees to each other, find the magnitude and direction of the resultant force. So the first thing you should do is to what? To draw the two vectors and how they incline to each other. So if you have something like this, you draw what? An horizontal line making an angle with what? A slant line. So we can assume that this slant line is the 2 Newton force. And remember, they are acting at a point O. So this is your point O. Then this horizontal vector or force, let me put it at the middle. Let's see this one as the vector, as the force 3 Newton. So I haven't drawn the two vectors, okay? And remember, the two vectors are inclined at an angle of what? 60 degrees. Now, I haven't drawn the two vectors like this. The next thing you have to do is to form a parallelogram from these two vectors. And I remember in our previous class, under the part 2 of scalars and vectors, I told you that a parallelogram is a flat shape with 4 straight lines in which what? The opposite sides are what? Equal and parallel. So let's form a parallelogram from these two what? Vectors. So how are we going to do it? We'll draw a line that is parallel to this line. Let's say, so this one is a slant line. So this one will also be what? A slant line. Then we also draw a line like this parallel to this line. So we'll draw something like this. So we have formed our what? Parallelogram. So let's see as point A. Let's see as point B. Let's see as point C. Now, for a parallelogram, it means that the side AB is equal and parallel to the side OC. So also, the side OA is also equal and parallel to the side BC. So that means this place will be what? 3 Newton. Right, this side will also be what? 2 Newton. Having drawn the parallelogram, the question now is, how do we find the resultant vector or the resultant force? Now, for you to find the resultant force, you must remember the law, the parallelogram law of what? Vectors. We say that what? If two vectors are represented in magnitude and direction by the adjacent side of a parallelogram, the diagonal drawn from the point of intersection of the two vectors, this is the diagonal, drawn from the point of intersection of the two vectors, represents the resultant vector in magnitude and direction. So this our line now, which is the diagonal now, will be the what? Your arrow, which is the what? The magnitude of the resultant vector, or the magnitude of resultant force in this case, because we are looking at what? The vector force. So this arrow stands for the magnitude of the resultant what? Force. Now, how do we get the direction of the resultant force? Now, the direction of the resultant force is the angle that this diagonal, which is the magnitude of resultant force now, makes with the horizontal. And let's see it as alpha. So what are we looking for now? We are going to look for what? This arrow, which stands for the magnitude of the resultant what? Force. And we are also going to look for what? This symbol, alpha, which stands for the direction of the resultant force. So the question now is, how do we find this arrow? Now, for us to find this arrow, you have to detach this triangle OCB from this parallelogram OABC. So let's bring out this triangle OCB out. Now, in bringing out the triangle, we have something like this: the horizontal line, the slant line, and the diagonal. Here is your point O, this is your point C, this is your point B, then this is the line arrow, then this is the angle that the diagonal makes with the horizontal, which is the alpha. Then your side OC is your 3 Newton. Then your side CB is your 2 Newton. Now the question now is, how are we to find the arrow and this angle, which is the alpha? So in finding the arrow, which is the magnitude of the resultant force, we use cosine rule. And cosine rule is used in a triangle. Any kind of what? Triangle. You can use what? Cosine rule. And the cosine rule says that the square of the side that you are looking for, you can look for what? Arrow. So the square of arrow equals to the square of the other side, one of the other sides. So let's say CB squared plus the square of the last side, OC squared, minus 2 times one of the sides, CB, times the other side OC, cos the angle that is facing the side that you are looking for. So let's see this angle that is facing this side that we are looking for. Let's see it as small arrow. So let's put what? Cos small arrow there. So the question now is, we know CB as 2. We know OC as what? 3. So the same thing applies here. But we don't know arrow. The question now is, how do we get arrow? We'll get arrow by coming back here. Because do this now, it means that from here to here is your arrow. So how do we get arrow here now? If you extend this line, like this, before we come here, let me quickly explain something in mathematics called transversal. Now look up. If you have a parallel line like this, these two lines now, they are parallel. So in mathematics, the line that joins two parallel lines together is known as the transversal. So if one of the parallel lines makes an angle with the transversal, let's say x, this angle that this parallel line makes with this transversal must be equal to the angle that the other parallel line makes with the transversal on the same side of the transversal, which is what? To the right of the transversal. So if here is x, here will be x. These two angles are called corresponding angles. So these two angles are what? Equal. So that's why I say in mathematics, corresponding angles are equal. But if one of the angles is here, the angle here cannot be equal to the angle here. For the two angles to be equal, the parallel line must make the angle with the transversal on the same side of the transversal. As you can see, this one now makes an angle of x on the right side of the transversal. This parallel line too also makes an angle of x on the right side of what? The transversal. So that's why these two angles are equal, and these two angles are called corresponding angles. And this is what we apply here too. So how do we get this small arrow now? So this is a parallel line. This line OA is a parallel line. Then this line CB is a parallel line. Then this line OC and its extension is the transversal. So if this parallel line makes an angle of 60 degrees with this transversal, it means that this other parallel line CB will also make an angle of what? 60 degrees with this what? Transversal. So if here is 60 degrees, in mathematics, they said angle on a straight line is equal to what? 180. So these two angles here, this arrow and this 60, they are angles on a straight line. So if the two of them are angles on a straight line, it means that the addition of the two of them will give you what? 180. 180. So if the addition of the two of them gives you 180, so that means if you say arrow plus 60 degrees is equal to what? 180 degrees. Because of why? Because they are what? Angles on a straight line, and angles on a straight line gives what? 180. Therefore, from here you have that arrow will be equal to what? 180 minus 60. So your arrow will be equal to 120 degrees. So this your arrow is now what? 120 what? Degrees. So we have gotten what? Our arrow. So now we can now apply this cosine rule in full. So in getting our arrow now, we now have arrow squared is equals to your CB, this side CB, that CB is what? 2. So we have 2 squared plus this side OC 3. So we have 3 squared minus this 2 times bracket, opening bracket means what? Times what? CB. Your CB is what? 2. Close the bracket times OC. Your OC is what? 3. Times cos your arrow now. The arrow, we have gotten arrow to be what? 120 degrees. So arrow squared will now be equal to what? 2 squared means what? 4. Plus 3 squared means what? 9. Minus 2 times 2, 4. 4 times 3, 12. We now have 12 times cos 120 degrees. Arrow squared will now be equal to 4 plus 9 will give us 13 minus 12 times cos 120 is equals to minus 0.5. So arrow squared will now be equal to 13 minus 12 times minus 0.5 will give you plus 6. So arrow squared will now be equal to 13 plus 6 will give you 19. So what we are looking for is arrow and not arrow squared. So how are we going to remove the square? You remove the square by taking the square root of both sides. So this will now become what? Square root arrow squared equals to square root 19. Where the square root cancel the square, here will now be what? Arrow equals to the square root of 19 is approximately 4.36. What will be the unit? Newton. Because you are looking for what? Because this is what? The resultant what? Force. And the unit of force is what? Newton. So your arrow, we have gotten arrow to be what? 4.36 what? Newton. And this arrow is the magnitude of the resultant force of these two vectors, 2 Newton and 3 Newton. Now to get the direction of the resultant force, which is your what? Alpha, you use what we call the sine rule. And sine rule says, sine rule says that the sine of the angle you are looking for, which is alpha, divided by the side that is facing the angle, which is what? Side CB, is equal to the sine of any other angle and which in this case, the other angle outside alpha is what? Your angle what? Arrow, which you have already calculated to be what? 120 degrees. So sine arrow divided by what? The side that is facing what? The angle arrow, and which is your what? Your side OB. So with this equation, with this sine equation, we can find our what? Alpha, which is the direction of the resultant force. So from here now, we now have sine alpha all over side CB. Side CB is what? 2 equals to sine arrow. So sine, your arrow, we have already calculated it as what? 120 degrees divided by side OB. OB, that's your arrow. And your arrow, that's capital letter arrow. And capital arrow, which is the magnitude of the resultant force, has already been calculated. And we got what? 4.36. So this place we got 4.36. Now you what? You cross multiply. So this will come and meet this. So we now have 4.36 times sine alpha equals to this come and meet this 2 sine 120 degrees. So what are we going to do now? You divide both sides by what? 4.36. So that what will be left this way will now be what? Sine alpha. So if you divide it like that, we now have 4.36. You also divided by 4.36. So this, we cancel this. What will be left here is what? Sine alpha equals to 2 sine 120 degrees divided by 4.36 will give us 0.3973. What are we looking for? We are looking for alpha and not sine alpha. So what are we going to do? We divide both sides by what? Sine. So if you divide here by sine, you also divide here by sine. Sine, we cancel sine. What is left here is what? Alpha equals to, there's an imaginary 1 here, because 1 times anything will give that thing. So this 1 now, 1 divided by sine is seen as sine inverse. That's sine raised to power minus 1. Then you now put this number, you now put it here, 0.3973. Alpha will now be equals to the sine inverse of 0.3973 is 23.4 degrees. So your alpha, which is your direction of the resultant what? Force, is what? 23.4 degrees. So we have been able to what? To find the direction of the resultant force and the magnitude of the resultant force. Before we go, take this assignment and put your answer in the comment section. They find the resultant of two vectors of 3 units and 4 units acting at a point O at an angle of 45 degrees with each other. As I said earlier, put your answer in the comment section. With this, we've come to the end of today's class. If this video has been helpful, please give it a thumbs up. Click on the notification bell if you have not done that already, so that whenever I post, you'll be the first to see the video. Also comment, say something about what you think about this video. Also share to as many people as possible. And above all, please subscribe to this channel. And as you do so, may God bless you richly. One love.